Suppose we know that a confidence interval is 67.18 to 68.82, and we want to find the error bound. We may know that the sample mean is 68, or maybe we only know the confidence interval and we don't know the sample mean. How do we backtrack, given this confidence interval, to find the error bound and possibly even find the sample mean? Well, the good news is that if we're given the interval, we can fairly easily go backwards and find our error bound and our mean. It's very typical for articles that give confidence intervals to not show all the steps, but to sum up the steps in, we created a 90% confidence interval and here it is. They would do it more eloquently, but you get the idea. So reading article, a journal article or a newspaper where they're doing confidence intervals, they don't give you the methodology spelled out. They'll tell you in simple terms what they did, and then they'll give you their solution. But if we want to recreate it, we need to do some backtracking. So let's try some backtracking. If we know the sample mean is 68, we can calculate the error bound. And we do that in that we take either limit and subtract the mean from it. And notice this works for either. We just have to subtract the lower one from 68 and subtract 68 from the bigger one. So we only have to do one. I do want to emphasize that. We only have to do one of these two calculations. But they will both give us the same answer. 68.82 minus 68 is 0.82. So I know my error bound is 0.82. But if I switch it around and I use the other numbers, 68 minus 67.18, notice I get 0.82 again. Also, in case I forget the order that I subtract them in, let's say I accidentally switch and I do the smaller number minus the mean, I get negative the error bound. It just means we subtracted them in the wrong order, but that error bound is still there. Your error bound should always be positive, so that's how I know I switched the order and I got a negative answer. If we don't know the sample mean, to calculate the error bound, we really need to find the width of our confidence interval and divide it by 2. Remember that in our structure for our confidence interval, we take the mean and add the error bound, and we take the mean and subtract the error bound. And this subtracting and adding cause a double error bound in the whole interval. So we take our two numbers, 68.82 minus 67.18, divide by 2, and that's going to give us our error bound. So 68.82 minus 67.18 gets us 1.64. Divided by 2, it's 0.82 again. Now what if, instead of trying to find the error bound, we need to calculate the sample mean? So we know the error bound is 0.82 and we need to calculate the mean. We can do something similar as we did in the first part of our problem. We can take the upper bound and subtract the error bound. So we're doing the opposite of what we did to get it. Or, switching it around, we take the lower bound and we add the error bound. Again, doing the opposite of what's given. We only need one, but I'm showing you both to show you that they're both equal. 68.82 minus 0.82 gives us 68. 67.18 plus 0.82 also gives us 68. So we can find that mean pretty easily. We can find that mean doing a simple add or subtract to our interval. Remember, the mean needs to sit directly in the middle of the two numbers that were given in our interval. The sample mean sits exactly in the middle. If we don't know the error bound, and we still need to calculate the mean sits in the middle, so we are going to average the values of the interval. 67.18 plus 68.82 divide by 2. We find the average, we get the middle. So 67.18 plus 68.82 gives us 136. Divide by 2, and we get 68. So we can recover the mean and the error bound just from being given the confidence interval.